This is 8.4, integrals of sine and cosine functions. So in the last video, we did derivatives of sine and cosines. Now we're going to do the integrals of sine and cosine functions. So very basic integral of sine. It's going to be negative cosine. Integral of cosine is going to be sine. And that's just because the derivative of sine is cosine. The derivative of negative cosine of x is sine of x. Okay, so let's just go ahead and just jump right in and let's do some problems. Now, a little disclaimer. I would just say use any integration techniques you have learned. Okay, and that involves U sub, okay? It also involves integration by parts, okay? Anything that you can possibly think of, that's what you want to be able to do, okay? Maybe not partial fractions, but yeah, you want to be able to do these types of things, okay? So let's do an example. Okay, so we want to integrate. Let me just write integrate here so that there's some directions. Okay, so what you want to do, you want to take the integral of cosine of t minus sine of t dt. Okay, all right, there's really nothing to this integral. All we have to do is just take the antiderivatives. Okay, so the antiderivative of cosine, well, we just figured out what cosine was. It's just sine of x. It's going to be sine of x. Minus the antiderivative of sine of t is just going to be negative cosine of t plus c. Okay, negative and negative is going to give me a positive, so sine of x plus cosine of t sine of t plus cosine of t plus c. Okay, so this one was just a straight up, just look at the integrals and then just plug them in. Okay. All right, now let's do this one. That was part A. Let's do part B. So let's say we want to do the integral of t squared sine t cubed plus 1 dt. Okay. So if you look at this, it looks a lot like integration by parts because you can see that two different functions are being multiplied to each other. But also remember that is U sub maybe probable? Well, a U sub basically means that a derivative is somewhere in the function. And you can see that you have the inside function here, t cubed plus 1, and you have something on the outside, t squared. So it seems like U sub might be really probable. So let's go ahead and do that. So let u be the inside function, which is t cubed plus 1. So the derivative of this is going to be equal to 3t squared dt. I divide by 3 over. I'm going to have 1/3 du equals t squared dt. Okay? So this is going to be my u substitution. Okay? So what I'm going to have is I'm going to have the integral, okay, sine of whatever the inside function was, which in this case was u. So this thing is u. Then you have this t squared and dt, which is equal to 1/3 du. So 1/3 du. Okay, so I'm going to take out the 1/3 out, and I'm going to have the integral of sine of u du. Okay, so the integral of sine of u, well, we already know what that is. That's just going to give us negative cosine. It's going to be negative cosine of u, and then plus c. Now we know what u is. U equals t cubed plus 1. So we're going to have this negative outside, negative 1/3 cosine of t cubed plus 1 plus c. Okay. All right, so notice that we didn't have to use integration by parts in this problem. Okay, now let's do another one. So let's say you want to do the integral of x sine x dx. Okay. All right, so in this case, notice that a u sub is not going to be able to happen because the inside function is not the derivative of the outside thing. Okay, so in this case, integration by parts is probably what you want to do. So we're going to set up our u du and our dv and our v. Okay, now if you remember our acronym, LH, we're ignoring the inverse functions. Okay, A should be algebraic, so in this case it's going to be x. The derivative of this is going to be dx, 1 dx. dv is going to be sine of x dx. MV is going to be the antiderivative of sine, which in this case is going to be negative cosine of x. Okay, now let's go ahead and do the integration by parts. So you have that x times negative cosine of x minus the integral of negative cosine of x dx. So this is going to give me negative x cosine of x. Negative and negative can be a positive integral of cosine of x dx. So then you're going to have negative cosine of x. Integral of cosine is just going to be sine, so plus sine of x. And then plus c. Okay. Alrighty. Okay, so now let's do another problem. So let's say we wanted to do the integral of sine x over cosine of x dx. Okay. All right, so here what you might want to do, you might want to let u be equal to what? Well, if I make it equal to sine, then you have this cosine on the bottom. It's better to have it on the bottom. And another way that you can kind of think about it is maybe make it like this. You can also write it as integral of sine of x and then cosine of x to the negative 1, if in case it's really difficult to figure out. So I'm going to let just u be equal to cosine of x and du be equal to negative sine of x dx. Move the negative over, negative du is equal to sine of x dx. So what that's going to give me is the integral of the inside function, which in this case is going to be u to the negative 1. And then the sine x dx, this whole thing is just equal to this negative du, Can take out the negative outside, integral of u to the negative 1 du. The negative is on the outside. The integral of u to the negative 1 is just the natural log of the absolute value of u plus c. Okay? And then finally, you just want to go ahead and plug in whatever u should be. U in this case was cosine, so it'll be negative ln cosine of x plus c. Okay? So now that you kind of have the gist of it, you can do many different problems just using the same thing, use substitution or integration by parts or anything like that. So